These are your notes on probability. This is just an introduction to probability, but I feel like a good majority of the questions that we see on the SAT or PSAT involve just simple understanding of probability. Probability can go get really complicated, just like statistics can. You can get into multiple, where you have to multiply the different concepts or add them. Has a difference between and or, that sort of thing, all the different choices. But if you get a good sense of probability, I think you'll find it not too bad. So the actual definition of probability is a ratio. So it's just a comparison between numbers. And depending on what they're asking for, a success is what they're asking for, the desired outcome. Failures are all the other outcomes. So successes and failures should actually add up to 100%. So we usually use it as a decimal, but sometimes we talk of probability as like a 50-50 chance. You'll hear that, and that's 50% probability of it likely happening, 50% failure, which makes up the total 100%. So it's on a scale from 0, so we have this little number line here, from 0, let me just get my pen going here. This represents 0 all the way down to 1 over here. So on the scale from 0 to 1, halfway would be 0.5. Okay, and so the closer to 0 you are, the less likely the event is to occur. The closer to 1, the more likely the event is to occur. And it's just kind of a measurement scale. So if you guys know some things that are the 0.5, like flipping a coin, true and false, you got a 50-50 chance of guessing the correct answer, but you have the same equal chance of correcting the wrong answer on a true and false. So it would be equally likely in the middle. 0 is impossible. This can't occur. And a probability of 1 is like 100%. This is certain. This is definitely going to happen. And not too many things in life are certain or possible, but then all the way the scale in between. Probability cannot answer when and why events occur, just the probability that they would. You can prove it wrong too. I could flip a coin 10 times and get heads every single time. So it doesn't mean that it's going to happen. It's just a likelihood. The more you flip the coin, the more you do the experimental probability. Like if I flip the coin 1,000 times, the closer I would get to the 5, the 0.5. 500 of the times would be heads, 500 of the times would be tails. So to find the probability, it is, I think I have to erase this, the successes over the total of successes and failures. And the probability of a failure are just the remaining amounts, failures over successes plus failures. So the S plus F is just your total. And that's why we've been working on figuring out totals with the counting principle and permutations, combinations, that sort of thing. Sometimes probability can get that involved. Ours is pretty simple here, just kind of kept to the basics. So let's go ahead and give it a try. By the way, before we get started, sometimes problems involve the sum of two dice. I think we did this problem earlier. It is nice to have this chart when we did permutations and combinations. I just put it in your notes so you'd always have it, and then a deck of cards. And I know a lot of you guys, sadly, do not play cards all the time, and so understanding what cards are is a little confusing at times. So let's just go ahead and finish this up really quick. So it's like a multiplication chart, but we're adding. So when you have two dice, these sums, 1 plus 1 is 2. You got 3, 4, 5, 6, 7. And then 2 plus 1 is 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. So I just want to quickly kind of see a pattern here forming. And take a second to fill out this chart because it might come in handy later on, either in homework, tests and quizzes, or I think in the notes I do reference it. All right, quick little lesson on cards. There are 52 cards in a deck. There are 4 suits. These are your suits. This is a diamond. I think that's pretty obvious. This is hearts. That's also pretty obvious. This is a club or clubs, and this is spades. Think of like spades, like a shovel. Sometimes people call shovel spades, kind of looks like a shovel. So those are your 4 suits. There are 2 red and 2 black. That's why we love using it in probability, all the sorts of different combinations. Your cards look like this. So there's 13 total in each suit. And so the 13 times 4 suits is where you get the 52 cards. This little A is an ace. Sometimes we count ace as 1. It only has 1 heart on it. Sometimes we count that as the highest card, higher than the face levels, or as the lowest card. So in this particular sequence, these are your lowest cards all the way going to your highest. So it looks like it's showing ace is high. In many games, ace is higher. Notice that J, Q, K, and then the A. The J, Q, K, these are called face cards. They kind of go in that order. This is your jack. This is your queen. And this is your king. So if you think of royalty, the king is the highest. The queen is underneath the king. And then a jack, think of it like I always think of it like a son, like a prince, but they call it a jack instead of a prince. And then aces would be higher than all of those in that particular case. So we don't really get into that because that's all about playing cards and not using them. But you can use this as a reference as you move forward. All right, so let's go ahead and just try a few of these. So in a bag of marbles, there are 3 green, 2 red, and 5 blue marbles. Find the probability of each below. So the probability of selecting a red marble. All right, so we're trying to find red. That's our desired. That's our success. Notice we have 2 red marbles, but it didn't tell me my total, so I do have to add them up. I'm not using counting techniques. It's just marbles in a bag. So I have 3 green, and the 2 red makes 5 plus 5 more blue. So there are 10 total in this bag. That's kind of nice to know. So the probability of selecting a red, there are 2 successes out of the 10 would be red. So 2/10, sometimes we write it like that. You could also write it as 1/5, but we're just going to simplify things and give me the decimal. And again, they also do 20%, but I believe, unless they ask for the percent, one of these 2 is sufficient. Part B, probably of not selecting a green. So your success is not green. So when we write this out, by the way, we put a P and then we put not green in our parentheses. We kind of did this a little bit with our counting techniques. Up here, this would be probability of red. If there's multiple things, we put a comma between them. So the probability of not green means everybody but green. So that would be the 2 red and the 5 blue. So 2 red and 5 blue makes 7 out of the 10 marbles. Okay, and that's 0.7. You could also think of it, well, as the failures. So the failures would be green. That would be 3 out of the 10, and so the other 7. So 0.7 there. I'm going to add a C to this. I'm going to say the probability of purple. What is the probability of selecting a purple marble? Not saying that red and blue make purple, but there are no purple marbles in this bag. So big fat 0, impossible, right? If I have a bag full of red, blue, and green marbles, I cannot select a purple. That would be a probability of 0. Let's try another one. In a standard deck of cards, the probability of selecting a red king. So we're talking about a red king. There are 2 red kings. So probability of red king. There are 2. If you got to go back to that other page, but there's the King of Hearts. And there is the King of Diamonds. So there's 2 out of 52 cards. So 2 likely, that was my success. Out of 52, not very likely. If I just randomly selected cards, probably not going to pick a red king. That doesn't mean it's not going to happen, and we just round this. So 0.04. So do you see how 0.04 is very close to 0, not very likely? The probability of selecting a face card. Well, on that last page, I did mention that the face cards, there are jacks, queens, and kings for the 4 suits. So this is sort of like the counting technique. We're doing the probability of face card. To figure out how many face cards there are 3 face cards and there are 4 suits. So there are 12 total faces. Aces are not faces. And so there's 12 total. Of the 52, 12 of them are face cards. You could also just list them out. You could say, well, the 4 and list them all out. You could also say hearts, diamonds, clubs, and spades, and then go through them this way if you really needed to. But lots of different ways to count up that there are 12. 12 divided by 52 is 0.23 probability, a little bit greater, almost 1/4. 1/4 would be like a multiple choice test. It's not really that great. It's a little less likely, not equally likely, closer to 0, but not as close as like a red king. The probability of not selecting a club. So not selecting club is probability of not club. Okay, so not club, well, of each of these, there's 52 total cards divided by 4 means, and I told you there's 13 in each suit. And so there's 13 clubs. So if you do 52, take away those 13 clubs, that leaves us with 39 not clubs. So 39 out of the 52, your chances are pretty high of not selecting a club, quite high at 0.75. It's 3/4, right? You could also say club is 1 suit out of the 4. So then not club would be 3 out of the 4. That's another way of doing that rather than counting the actual cards. You could divide by the suits or calculate by the suits. We get 0.75 either way. All right, when rolling 2 6-sided dice, we're going to go back to that picture in the front. What is the probability of the sum being less than 4? Oh, sorry about that, Val. Probability of sum less than 4. So it does not include 4. So if I go back to that page and find all the numbers that have a sum less than 4, so that would be all of just those 3, actually. Everything else is a sum bigger than that. Didn't say equal to 4, so I have 3. Notice you have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 36 different sums, possibilities, right? Some repeat, but there were 36 choices. So we're doing 3 out of the 36 here. That's going to be our probability. So going back to this, 3 out of 36 is 1/12, and 1/12 is 0.083, repeating. So not very likely, because and you looked in the picture of it, there weren't very many. What is the probability of the sum being 7? We can go back to that graphic. So if it equals 7, we can go back here and see that it's that whole diagonal. So we got 1, 2, 3, 4, 5, 6 of them are all 7s. So 6 out of the 36. That's 1/6 as a fraction, and 1/6 as a decimal is 0.16 repeating. All right, almost done. This is just a multiple probability or a little bit more complicated event just because totaling up the 3 coins. So remember, you have 3 coins, and each of the 3 coins has 2 choices, right? And so a lot of people think, so it might be helpful just to have first coin, second, and third, if you're trying to figure this out. But there's actually 8 different outcomes. I know we want to say 3 times 2, but each coin has 2. So it would be first coin, heads or tails, second coin, heads or tails, and third coin could also be heads or tails. And so you end up with, why do I have? I should have 8 different possibilities. Oh, I know what it was. Not like this. We could have heads, and then I could do heads again and tails, but I could do heads again here and then tails, heads again here and then tails. This is how the actual tree diagram goes. So there's actually 4 choices for heads, and then you could also do tails first, then tails, or then heads if it's tails second. So it's kind of first, second, and third. Can't really do it this way. That's a little misleading. It would be first coin has 2 choices, second coin has 2 choices, third coin has 2 choices. So the counting principle does give you 8, but so does the tree diagram. If I had tails, then heads, then tails, then heads here. So those are all your different choices. This particular case, it would be helpful to have all 3 of have the actual outcomes. So I'm doing the 3 going down the page. If you guys can kind of see, each branch is a different coin. So this is first coin, this is second coin, and this is third coin. But now you have all the outcomes. All 3 coins will land heads up. So that's probability of heads, heads, heads. And so 3 heads, if you look, can't be anything on that second tree diagram, right? So this would be all, so started with the tails. And then if we go over here, all 3 heads come off my page here. I got heads, heads, heads right here. That was only 1 out of the 8 outcomes. So finding those outcomes is a little tricky. In fact, I even started off wrong here. I mean, that's telling you the first coin choices, second coin choices, 3. That leads me into the counting principle, but when you're actually listing them, you want that tree diagram over here. So they can get a little tricky that way. I don't think I gave you any like that. The coins will land 2 heads and a tail. Doesn't say what particular order. So probability of 2 heads, 1 tail. So when we look at that information, we are looking at any one of these combinations where there's 2 heads and a tail. So that would be 1, and then 2 in that one, 3 right there. And that's all of them that have the 2 heads and the tail. So that would be 3 out of 8, which we could get the decimal for as well. This is 0.125. I believe that's 0.375 or 0.38. Another way to get those 2 is you could just list them. Heads, then heads, then heads, 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 tails, heads, tails, heads, heads, tails, tails. First coin, second coin, third coin. And then repeat all of that with tails first. So you got to sometimes see the results. I know we can count, but sometimes it's helpful to actually see them. So that's where those lists and tree diagrams come into play. And then just lastly, I do see these showing up maybe on testing info and just being able to see the graphic. So it's a little bit more of a bar graph, but they're just showing you the outcomes, either in a table or in a histogram little graph. And so you're just interpreting the data. This is what we've been writing. They see that. You should be able to interpret. They're asking for the probability where the heads is equal to 0. It's in a table, 1/8. Also over here, it's in a graph, 1/8. So just being able to piece through the information in a graphic. Probability of heads equals 2, 3/8. Here is also showing 3/8 in a picture, in a table, and being able to identify what other outcome has the same probability as found in part A. So I'm looking for another 1/8. That would be 3 heads. And also right here in the graph. So just some other ways to see that same information. All right, good luck. I got a worksheet for you, and we will work on that in class.